Finding the snowiest month. This will be our fifth Pandas use case. In this video, we are going to take a look at asking a business question, which is the snowiest month, and answering the business question using Pandas and EDA techniques. Let's head over to our notebook. We quickly get our inputs out of the way. Now we saw earlier that Pandas is really good at dealing with dates. It is also amazing with strings. We're going to go back to our weather data this time. So we read the CSV from the data folder, and we're going to move on and try doing some string operations. Now you'll see that the weather column has a text description of the weather that was going on each hour. We'll assume it's snowing if the text description contains snow. Pandas provides vectorized string functions to make it easy to operate on columns containing text. There are really some great examples that I've embedded in the documentation. So we'll subset out from the weather data the weather column, which contains our text description, and then we are going to use a convenience method in Pandas, which is .string.contains, to extract out or to subset out rows containing the word snow in the column weather. And once we have it, we get a binary vector, which is a bit hard to look at, so we're going to plot it. So if we try to look at it at the raw form, it really doesn't make more sense. It really doesn't make much sense. So what we are going to do is try and plot it to see if it makes a little more sense. So we see that these bars that we see across the plots, where the x-axis contains the months, are the places where there have been snowing, are the times where there was snow in the weather report. So we mostly validate our understanding by seeing that the winter seasons have got mostly the clusters of the snowy days. Using resampling to find the snowiest month. If we wanted the median temperature of each month, we could use the resample method like this. So we take the weather data, take the temperature column, and then resample it to find the median and then plot it. And we see that these bars contain positive as well as negative values. Unsurprisingly, July and August are the warmest. So we think of snowiness as being a bunch of ones and zeros instead of true and false. So we are going to encode our data by changing the is snowing to a float and then try to look at some of the rows. Now we are going to resample out of this data to find the percentage of time it was snowing each month. So we take the is snowing dataset again, convert it to float, resample it to find the median. And there we have it. So whatever number that we see in front of us in this output data frame can be interpreted something like this. The closer the value is to 1, the more snowy it was on that particular month. And so if we plot it, we get that it was most snowy in January, December, especially December. So December was the snowiest month. Also, this graph suggests something that I feel. It starts snowing pretty abruptly in November and then tapers off slowly and takes a long time to stop, with the last snow usually being seen on April or May. Plotting temperature and snowiness stats together. We can also combine these two statistics, the temperature and the snowiness, into one data frame and try plotting them together. So in the first line, we have our typical code which takes the temperature data and does a resample on it to find the median, and the next line subsets out, and the next line subsets out the months whose text description contains the word snow. And then we take those Boolean values, convert them to float, and then resample them again to find their mean. And then finally, we rename our columns to have a consolidated data frame containing both these modifications. We'll use concat again to combine the two statistics into a single data frame. So we use pd.concat of temperature and snowiness, and we want to specify the axis equal to 1 because we want to do a vertical join. If we look at this data, we see that indexed by time, we have two columns in this data frame, temperature and snowiness. So if we decide to plot it this time, we'll be able to see temperature and snowiness together in a bar chart. But if you look at it really carefully, it didn't work so well because the scale was wrong. Snowiness is a parameter that we are measuring that contains values between 0 and 1, and temperature, somewhere values are ranging between -10 and +20. So they aren't really in the same scale, and hence we cannot see the purple plots of snowiness. So what we are going to do, we are going to use the subplots equal to true parameter in the dot plot method, specify our figure size to come up with two different plots on the same canvas, one for temperature and one for snowiness. And there we go. So we now have two different plots, one which shows the temperature and one which shows the snowiness. And using these plots, we can now easily conclude which was the snowiest month.